Hello, I'm Lorna Alcott, chair of the Highland Royal Stat Society local group, and it gives us great pleasure to welcome you all to this. I suppose it's our tribute to the Women's International Day. This is our version of it, and I have to do. We've got two speakers today. I'm going to hand over to Altia, who has on this occasion been the one to organise everything for us. So Altia, would you like to introduce the speakers for us?
Thank you, Lorna. Can you hear me well? Do I have a way of return? Okay. Happy International Women's Day, everyone. And it's an honor for me to introduce first Professor Alison MacFarlane, who led research in the Department of Midwifery at City University of London until retiring into a part-time position in 2011, although she remains very active, as you all know. And she previously worked as a statistician at UCL, the London School of Hygiene and Tropical Medicine, and the National Perinatal Epidemiology Unit in Oxford. She is an active committee member of the Royal Statistical Society History of Stats section, which co-organizes this event with us. And her research interests lie in the interpretation of and use of official statistics and the relationship with policy, health, and healthcare in the widest sense, as well as to maternity issues in particular. So it's very fitting that Professor MacFarlane will be talking today about Enid Charles, socialist, feminist, demographer, and her analysis of the timing of birth. So without further ado, I'll pass you on with Alison. Thank you very much.
Thank you very much, Altia, and thank you for inviting me to Aberdeen, even if only virtually. I've only once given a talk in Aberdeen before, and that was for the retirement of a remarkable woman, Marion Hall. It may be there's someone in the audience who knows her work. She was actually the first woman to be appointed a consultant obstetrician in Scotland. And of course, on that occasion, that was in prehistoric times when you caught a local train to Luton Airport Parkway, caught a plane to Aberdeen, and actually went to Aberdeen. Now we're not allowed to go abroad, and now I know that the Scots language is an official language on Spotify. I now have to learn a new language before I come and see you. Anyway, back to the subject of talk, Enid Charles, and a disclaimer that I know two particular papers of hers, which I am going to talk about, but I'm also going to talk about her life and contributions to demography, because she was primary demographer. And this is based entirely on the work of a Canadian demographer, Sylvia Vargon, who first wrote a tribute to her on the 100th anniversary of her birth, and then wrote a longer piece. And so that I'll start with her work, telling you about Enid Charles's background. She was born in Denbigh in Wales, and her father was very keen that she went to university. From 1913 to 16, she studied maths, economics, and statistics at Newnham College, Cambridge. In those days, women could do the course but not get a degree. That was changed in the 20s when she paid the relevant fee and got a degree. She went to Liverpool for a year to do a course in social science, but left after 10 months to live with the biologist Lancelot Hogben, who she'd met in Cambridge. And though she was very against the institution of marriage, the inevitable happened. And in 1918, when she was found she was expecting their first child, she got married, but she vehemently kept her own name. And first 12 years of her career wasn't really a career. She did what married women did at that era, particularly in the 20s when women were coming out of the workforce, which they may have been during the war. She followed her husband from job to job, and there were quite a few of them. He was very distinguished academically, but his tact and diplomacy weren't amongst his skills, so he tended to move around. During this period, she had 3 more children, they spent some time in Canada, but when they got to South Africa, they were able to hire a Swedish housekeeper, and she was able to do a PhD, which she actually did in physiology, which was more her husband's subject. She left they left South Africa in 1930, not waiting for her degree to be awarded, a PhD, and she was annoyed that she'd had to give his name, and so her thesis was by Enid Hogben. And they fetched up at London School of Economics in the 1930s. And the director at the time was Beveridge, and he was keen to inject an element of biology into the study of social structure and changes. And he created for her husband a chair of social biology, and this is a definition given of social biology, which is the application of biology to human society. She was still writing her papers on physiology, but once she got to LSE, she turned her attention to human populations. And at the time, there weren't many demographers, and she was amongst one of the first demographers to challenge eugenics, which was prevalent in demography as it was in statistics at the time. And she became associated work with Population Investigation Committee, founded in 1935, included such people as David Glass. And given that the falling population in the 1930s is a matter of concern, this was their focus, but they did other work. For example, in 1946, they were behind the Maternity in Great Britain survey of a week's births, which continue to be followed up to this day as a 1946 birth cohort. And this group was originally founded by the Eugenics Society, but again moved away from it. And her work, she charted the declining birth and marriage rates, and she did population projections based on the rates in the 30s, and these are often referred to afterwards as predictions, which they weren't. They were what projections. These are the titles of the books that she published, which were fairly provocative. I couldn't actually get hold of copies of those books in lockdown, but this is from a paper she wrote in 1946, showing declining trends in reproduction during the 30s. This goes through to 1945, and there's a slight upturn, but at a time when she couldn't have predicted the post-war baby boom, which of course changed all the projections. And Eugene Grebenik, who I actually remember at the end of his career working with the Office of Population Censuses and Surveys, summarising her projections as saying that population of England and Wales was going to fall from 40.6 million in 1935, 17.4 in 2000, and 4.4 in 2035, which of course it isn't doing at all, because we had a change in those declining rates we saw in the previous graphs, turned around with post-war baby boom and other trends. To give us a flavour of what she was like, this is a review of one of her books from the New York Times, and describes her as having a caustic humour that affords many a pungent sentence. In fact, not only did she have a husband who was perhaps not easy to get on with, but apparently that she was not always that easy to get on with herself. In 1937, they moved to Aberdeen, and the biography I read doesn't say anything much about what she did in Aberdeen. She was Leverhulme Research Fellow in the Department of Natural History, and she contributed chapters to her husband's book, Political Arithmetic. And if anybody knows anything about her time in Aberdeen and her collaboration with any like-minded people who would have been there at the time, I'd be very interested to know. But in 1940, they started towards upheavals of the war years. She was invited to go to Canada to do a study of differential birth rates in Canada, which should have taken her about a year, whereas he was invited to spend a semester as visiting professor at the University of Wisconsin at Madison. He returned in 1941, but she stayed until 1946 with their two youngest children and worked for Dominion Bureau of Statistics, now known as Statistics Canada. And at the time, it was introducing new questions onto the Canadian census, and she busied herself. A lot of her published work comes from this time, and therefore was about a Canadian demographer. She contributed a wide evaluation of the census and vital statistics, and also lectured. Apparently, what work at this point, she was applying standard techniques, but making other innovations. For example, she suggested that using the term race wasn't appropriate, and they should use the term ethnography. Oh, sorry, ethnicity. So this is right back then. She then came back to England in 1946, by which time her husband had moved to Birmingham. And on previous occasions, he had jobs lined up for her. She got these jobs on her own. One was working at Birmingham City Council in its new statistical office. And then she went to work for two Birmingham hospitals. But she also had an appointment at the university. And her career in the RSS, she joined in 1947. And according to the chair of the history section, John Aldrich, who charts women statisticians, she didn't get an obituary, but he did. So the first of the two papers, which aren't mentioned in the chapter of her career as a demographer, but the two that I know, one was developing Birmingham's maternity and child welfare records, which were of course all manual at that time. And this building of data banks is something which may have been in the air. Thanks to Sahini Bhattacharya for giving me these slides from Aberdeen. You can see that in Aberdeen, work was getting underway to develop systems of maternity data. Aberdeen started with edge punch cards. You may not be able to see this very well, but here you see some edge punch cards and the needle you put through them. In Birmingham, they're more sophisticated. They used 80-column punch cards, which by that time, this is an early card punch, but by the 50s, they had developed complex counting and sorting equipment. This is a picture, for those of you who haven't seen it before, of an 80-column card, though it the punch cards and also paper tape survived in the computer era as a major method of data entry. But when used for data, each column was coded to a variable. And what she was trying to do was bring together the data provided to health visitors about antenatal care and details of birth, and then the data that the health visitors recorded in the first 5 years of the child's life, in order to give the schools some idea of their population coming in. And to do this, they needed to change the record. So this was the original record, and things are very compact. And when they changed them to go with the punch card system, you can see not very well, but that they inserted coding boxes in order to make the data entry easy. They took in the cards from health visitors at specified intervals and entered the data. And this is the sort of data they could get out of this. So looking at percentage of births in each of these areas to families living with 2 or more persons per room, which they collected on the health visiting cards. And here's the infant mortality rates, and you can see that it was high in the same area. Moving on to her paper on the hour of birth, which I've known even longer. This has been a long-standing interest in the timing of birth. This comes from Quetelet's book, Physique Sociale, which was written in the 19th century. As visualization is useful, and particularly for those of you who don't speak French, you'll see that births were most frequent in the 6 months, 6 hours after midnight, and less so in the evening. And this shows this only relates to 2 years, and the births were less frequent in the day. So it was a diurnal cycle then. And other studies in the up to the mid-20th century showed a similar pattern. But when she started this work, there'd been a correspondence in the British Medical Journal which had suggested that there are other studies that didn't show this pattern. And so she started an analysis. She was interested in the time of onset of labour, and her discussion is very much related to her background in physiology. She also analysed the time of birth and says, unfortunately, neither of these items were punched onto the cards. So this analysis of over 12,000 births was done manually using data from delivery records. She doesn't say how many people were involved in this manual analysis. It may have been more than one. And if you remember, before 1911, when punch cards came in, whole year's births were analysed this way. She said there were 2 reasons for doing these analyses. If it had been administrative, you want to know the workload and would have included all births. But so she was interested in what she describes as a process which initiate parturition. So she excluded the births which reflected some intervention or complications which may have influenced it. And describing what may lead to diurnal rhythms, she separated them into physical events, and particularly light and temperature. And many animals prefer to give birth at night, so it may not be surprising if humans do, and that may reflect light. But there's also the normal routines in the social environment, which equally are vary by day and night, but not directly physically. And then saying that on each of these cycles, she hypothesized there will be seasonal differences as well. So these are the tabulated. She tabulated the data by place of birth, and because it's a manual analysis, she restricted her analysis by season to births in 1 month's period surrounding the equinoxes and solstices, but also did additional analysis by parity, which is even more laborious because parity had to be extracted from the health visiting cards because it wasn't on the birth records. So this, which you can't see, is what her results look like. I've actually just chopped off the first of 2 tables given in the paper. And one is a tabulation by hour of onset and then by place of birth. So these are basically 2 lots of frequency distributions, which were then analysed graphically and with quite a lot of smoothing because the numbers were relatively small. So looking at the time of onset of labour by parity, and she did saying that onset of labour was difficult to measure. It was reported by the parents because it happened before the midwife arrived, and there were different definitions. I mean, these days, most systems don't record the time of onset of labour, but as a physiologist, this is what interested her most, and that first-time mothers' timings of onset were very much peaked around midnight, and it was less peaking for multipari, that's women who, gravidae, which is first and second pregnancy, that there was less of a marked effect, and they started to go into labour early evening. And then looking by place of birth, similar difference between home births and hospital births, but then she admitted that hospital births included more first-time mothers. So there obviously was some confounding, but on a manual analysis, she wasn't able to look into it. Looking at the full cohorts giving birth at the equinoxes and the solstices, she found that labour started earlier in the evening in March and was more concentrated in the middle of night in June. This is the timing of all births, and this is of actual birth rather than onset. And there's considerable variation because the numbers are quite small, but she, when she did moving averages, she found again that the peaking in the early hours of the morning. And this is a similar analysis for primogravity and multigravity, and you can see for time of birth that's particularly concentrated in the hours after midnight for them. She also looked of the distribution of the duration of labour, and here she's comparing first pregnancies and much shorter duration of labour in subsequent pregnancies, but also some difference between onset at day and onset at night. And her comment, obviously her summary summarises the findings I've shown you in her graphs, and she felt it was important to distinguish between solar time and that of the socially calibrated clock. In other words, what we do at different times of the day. And also felt that there's a tendency for normal labour to start more readily when the mother is at rest, if not actually asleep. She also comments that she felt that the analysis had raised more questions than it asked, and that it needed far larger numbers and obviously a lot more detailed analysis, cross tabulations, but that it commented that without mechanisation, the labour involved in inquiry planned on such a scale would be prohibitive. And so she'd done something that was innovative within the terms of what could be done in a manual analysis, which is pretty impressive. She didn't, unlike the people in Aberdeen whose data collection system continues and flourishes today, she didn't stay on to do more work. Suddenly, just to say that, show you, it was some years later, over 60 years before we got the larger scale study, which Mario and I are involved in. And it's notable that where births are spontaneous, like homes at birth, births at home or in freestanding midwifery units, we see the standard cycle that we've seen with the peaking in the early hours of the morning and the decline later in the day. But hospital births, which obviously constitute the majority of births in England, peak from 9 to 12 in the morning. There's nothing spontaneous about that. It's planned cesarean sections, which account for increasing amount of our births. But that was over 50 years before this larger study became available with large-scale computing, data linkage, and all the rest. Finishing up, I can see I'm 1 minute over. The rest of Enid, rest of her career, and she had then had a major change in 1953 where she split up with her husband. By that time, her children had grown up. The youngest would have been in their 20s, and started to work with World Health Organization in countries in Southeast Asia. And Sylvia Vargon says that this was probably her best work, but as it wasn't in the public domain when she was working on this, that you could only read it in the Library of the World Health Organization in Geneva. She retired in 1959 to the United States, which is where her sons and daughters, who'd obviously stayed or gone that side of the Atlantic, were. But she carried on doing consultancy work. But when the US developed policies in Vietnam, which she didn't approve of, to say the least, she decided to return to England, join a retire community in Exeter, and died in Exeter in 1972. So this is someone who perhaps most distinguished work is the most least known. The work I've talked about was in a way a side issue from her main career as a demographer, except that it was using her insights as a physiologist. And I've just finished with references to Sylvia Vargon's work and Enid Charles's papers that I've mentioned, plus a review of demographic research in Britain, which includes the work she did in the 30s. So that's it. Right, I think I press stop presenting here.
Thank you so much, Lorna. Perfect timing. That was a fantastic journey through a fascinating life and work. And we now have some time for comments or questions. So if you want to ask your questions, you can either raise your hand or add them on the chat. And you can either use your microphone or prefer not to have the video on because we need forms for that. But if you can add your question on the chat, that would be great. And I can't see anyone coming up. Oh, yeah, it's John Aldrich. Yeah, so if you want to put your microphone up, John, that would be great.
Okay. Hi.
Hello.
Hello. This isn't a comment. This isn't a question. It's a comment. As Alison mentioned, I've been interested in women statisticians of Charles's era. So let me say a few things about Charles. As far as I can tell, Charles is unique in being a married woman who worked in statistics in that period. So she's the only one I could find. I looked at her contemporaries. One of them is Hilda Woods. So these are women born in the mid-1890s. There's Hilda Woods. Hilda Woods' career was finished, in effect, when she got married. She got married when she was roughly 40. The two other women who I've looked at who are contemporaries. Jessie Douglas. Jessie Douglas has an obituary in JRSS. She was in effect a civil servant. She didn't marry. She had a full career. The fourth person, the fourth contemporary, it was Fisher's first assistant at Rothamsted, called Winifred Mackenzie. Winifred married in the, when she was roughly late 20s and left statistics altogether. So Enid was absolutely unique in being a married woman who had a career in this period. Her contemporaries either left statistics when they got married or remained single. So that's just by way of context. That's the end of me.
Can I comment on that? Because what struck me was when Enid Charles moved to Aberdeen in 1937, certainly in England, married women weren't allowed to work. So, for example, Janet Campbell, who's head of the Department of Maternal and Child Health in the Ministry of Health, and originated confidential inquiries into maternal death in 1928. When she married a Mr. Heseltine, she had to resign. My mother was a teacher in Croydon, and when she got married in 1938, she had to resign. But when Enid Charles went to Aberdeen, she seemed to have got a new job, and perhaps that legislation didn't apply in Scotland. So that was one thing. Also, her marriage was a little bit intermittent. She met up with her husband in late 1940 before he returned to England, and she didn't see him again till 1946, and they split up in 1953. And it's said that she did her best work after she split up with him. So that's a fairly unconventional marriage. But also, of course, the first 12 years of her marriage, she wasn't in employment at all. So perhaps you need an unusual marriage to flourish.
Thank you, John and Alison. Graham, if you want to ask your question next, and then we'll have a question from Tinkle as well.
Hi, Alison. Thanks very much for your presentation. The database using the needle, Sohini was kind enough to demonstrate that to me once, and I was absolutely amazed about how it was done. It really was such. It was just. Can you describe how it was done? It left me speechless because I was brought up with computers, and querying a database that way was just astounding to me. So many other people might not know how it was done. Maybe if you could describe that to us.
Well, I mean, I was lucky enough to start work just as they had gone out of fashion. But also my first job was at Rothamsted, that had one of the first computers in the country and very advanced counter sorters as well. But basically, those edge punch cards, you clipped the hole corresponding to how you'd got the, according to the code. And then what you did was align the cards, and you'd put the needle through and shake it, and the cards with that value would fall out, and then you had then you had to pile them up and count them manually. Maybe that as I didn't actually have to use it, I didn't have the special techniques that Sohini has mastered at this late stage. Is that how she showed it to you? Is Sohini here? She was thinking of coming.
I am, yes.
So that's right. perhaps if you could describe how you did what were officially called Cope Chat cards, but we call them knitting needle cards.
Yes, that's right. So you have a stack of cards which were arranged in order of the birth year. So, and if you wanted to know the number of preeclampsia cases in the year 18, that's going too far back, 1950, you picked up all your 1950 cards together, and the particular hole that goes along preeclampsia, you would put this knitting needle or the device that you showed in your photograph, which looks like an instrument of torture of some kind, but you put that through, and the ones who had preeclampsia wouldn't have holes, wouldn't have complete holes, but they would have notches. So the bit of the hole at the top would be cut off and they would just fall through. And as you described, you sit and count those. Does that help, Graham?
Yeah, I thought it was really ingenious and how you could do multiple, you could do 2 or 3 things at the same time. I thought it was wonderful.
Can I add another story to this? Apparently, Duggelbed got his idea of using punch cards to record labor things from the police station. So they used to keep criminal records in punched cards, and if they had a robbery in a certain area, they would put a knitting needle through the robbery in a certain area, and all the ones that came out were then tried to see if which ones were in jail, which ones were actually dead, etc. And then, how's that for an idea? How's that for interdisciplinary ideas?
Yeah, that's very clever. Thank you all. And if we can have the last question from Tinkle, and then we can continue this discussion after Mario's talk, if you don't mind.
Thank you. Yes, thank you, Alison, for an interesting talk. I just wanted to respond to John Aldrich's comments about women statisticians and marriage. Frances Wood is a woman statistician I'm interested in and I've written about. And she got married in 1911 and actually became a statistician after she was married. And she worked in the Ministry of Munitions till 1919 when she had a baby and died, sadly, in childbirth. But there's no doubt at all she'd have continued working afterwards. Her husband was very supportive of her. I shall say no more about Frances because I think Mario may mention her. Thank you.
Thank you very much, Tim. Without further ado, we will continue with Mario's talk. Professor Mario Cortina Borja is a professor in biostatistics in the Population Policy and Practice program at the UCL Institute of Child Health since 2015, but he's previously worked at the National Autonomous University of Mexico, at the School of Chemical Engineering in the University of Bath, at the Instituto Tecnológico Autónomo de Mexico, and the Department of Statistics at the University of Oxford. His main areas of research, amongst many, are epidemiology of infectious disease, modeling physical activity using accelerometer data, and the study of seasonal patterns, especially birthdays, and the effect of date of birth on adult health. So it's very fitting again. He's a member of the editorial board of Significance and member of the council at the Royal Statistical Society. And he's start on time today to talk to the Highlands Group and the history of stats section, and he's going to talk about Hilda Mary Woods and the negative binomial distribution. So Mario, whenever you're ready, thank you.
Thanks very much, Althea, for the invitation, and thanks also to Luz for technical support. Now, I'm not sure how to share my screen with you in this context. I suppose I say that. Just a moment. Yes. Does this work?
Yes, it does. Thank you. If you maximize it, that would be perfect.
Second. Excellent. Thank you. It's always daunting to follow Alison MacFarlane's talking about birth timing, and I would like to refer to somebody from Aberdeen University. In fact, probably the only time I was in Aberdeen that was to work with this person who Alison knew well as well is Professor Stuart Douglas, who was Regius Professor of Medicine in Aberdeen. And when he retired, he was a very eminent hematologist. He retired and, having no grants, decided to study seasonality on the grounds that it was cheaper than doing laboratory work. And I got to know him, I think through Alison, I can't remember this, in 1998, just before he died, sadly. And Stuart was a fantastic person, and he really, made me be interested in seasonality of disease. He was a very nice and very eminent hematologist, in fact, medical researcher. In fact, in October, it will be 100 years since he was born, and perhaps somebody should write a paper for significance about his contributions to seasonality. Anyway, as Althea mentioned, yes, I have my tartan tie, and as you can see, I also have a purple color for obvious reference to this 8th of March. So I'm going to start talking about Hilda Mary Woods and the negative binomial distribution. I will just develop the talk, and you'll see what happens there. Hilda, of course, has been already referred by John Aldrich, and well, let's talk about that. I want to talk about the context of 1910-1920 statistics in the UK, in the British Isles, in fact. Then talk very briefly about women in statistics. Again, some very important names have already been mentioned by Tim and by John and Alison, of course. Then talk about the biography of Hilda Woods, talk briefly about a refresher of the negative binomial, and talk even more briefly about the work of modeling accidents with a negative binomial, which is a really interesting paper. And I will just mention one example of that paper, of those data set in that paper, and then finish with the references, which is probably the more interesting part of the talk, really. Well, this is a demographics history of England and Wales, 1841 to 2009. This is the work of John Pattison et al. For the Society of Actuaries. You can see the dramatic, horrible effect of the First World War, particularly how the life expectancy decreases madly and then more or less recovers quite quickly, mostly in men, but also in women. It has a huge decrease around the First World War time. Well, this is just the context. I mean, it was. I think we have to remember, particularly in days of pandemic, how awful life was in the 1910s. Really, I mean, if you think of all the crises and all the war that there were in these isles, I mean, we are really not too bad. I have to say that. Anyway, this is what happens, and let me just focus on what happened in the two main statistical journals. I mean, on the other hand, the 1910s were a period of intense statistical activity. I mean, you just have to think of the big names. They are all there: Carl Pearson, Student, Fisher, Galton at the end of his life, Edgeworth. Everybody was publishing papers which were very, very important. David Cox and John Aldrich have written in Biometrica about the history of Biometrica, two fascinating papers, and I would encourage you to read them. It's a really interesting story how Biometrica started at the time of crisis again. I mean, the stories that they as far as I know, the RSS journal rejected a paper by Pearson, and then, well, this is a very caricature explanation, and then they founded a new journal because they didn't like the referees in JRSS. Well, again, I characterize this in a very light tone, but they founded Biometrica. Pearson named it, and Francis Edgeworth suggested the K in the name, I suppose, as a homage to Pearson, who knows, or perhaps just to make it more Germanic sounding. I don't know for sure. Perhaps John might know the story better, I'm sure. JRSS, founded in 1838 as the Journal of Statistical Society of London, was renamed JRSS in 1887. That name remained until 1984, when it was divided into Series A and B, and then Series C was incorporated as Applied Statistics in 1952. Series A was renamed, and the statistician was incorporated again to the Journal of the RSS as Series D, first with the name of the statistician from 1993 until 2003, and in 2004, Significance, the magazine of the society, appeared. I.D. Hill has a very nice history of the early years of the society and the journal in particular. I.D. Hill is an interesting person. I think Tim might have known him, I don't know. If you programmed at all in the 1980s or 70s, like I did, you may remember Griffiths and Hill, the series of algorithms in Fortran, of course, in statistical, in applied statistics. And I.D. Hill, I think, is also the son of Austin Bradford Hill, so a very interesting person too. Anyway, that's just the story of these two journals that dominated statistics in the UK in that decade. Well, this is a picture, it's a photograph of the two journals. I downloaded all the titles between 1910 and 1920. There were 163 articles published in Biometrica, 242 in JRSS. As you can see, Biometrica starts in Apache way, and then during the war, there is no publications in Biometrica. RSS more or less maintains the same number of articles per year. Now, these word clouds give you the flavor of the two journals. As you can see, Biometrica is a very focused journal. The words that dominate the titles are correlation, frequency, moments, samples, normal, and so on. There's also a lot more, as you would expect, perhaps with that name, a lot of biomedical or anthropometric papers in the journal. RSS has perhaps a more general or even social statistics or official statistics slant. As you can see, statistics, statistical, United Kingdom, population, economic, British, and so on are the titles that appear more often the words that appear more often in the titles of the articles in the journal. So quite different approach, I think, from both journals. And again, I'm sure John might have something better to say than I can, but this is a picture of what was going on in those journals. If we look at authors, well, that's the number of times that authors published in RSS and Biometrica, and you can see immediately the division. Either you tend to publish in Biometrica or RSS. Pearson, in 10 years, published 52 papers in Biometrica, 2 in RSS, but it's a lot more than that because of these 14 papers in Biometrica, most of them are signed KP. The World of Sciences engine give them as anonymous, but it was clearly Pearson's. And this in that decade, this one paper from Student, again, who's appears as anonymous. R.A. Fisher has a paper as well in RSS in 1914 about the small sample distribution for the correlation coefficient, which if you think of all these 405 papers published in the two journals, the one that has more citations than anybody else is Fisher's paper about the small sample properties of the correlation coefficient, which has something like 900 citations, and nobody else comes close about that paper. So again, that tells you the flavor of the decade, what the type of things in statistical methodology were being developed at the time. Well, I'm puzzled about Edgeworth because he suggested the name and so on, but then he didn't publish at all in Biometrica, while he published things in RSS. Not sure why. The persons in red, names in red, are women statisticians, and I would just mention a few. Again, Tim and John have mentioned a few notable women statisticians of the decade, or perhaps the 1920s. This is Ethel Elderton, a very remarkable person. As you can see, many papers in Biometrica. She collaborated with William Elderton, who was her brother, and he published, as you may know, the systems of curve distributions in 1908, and it was reprinted 100 years later by Cambridge University Press. It's a brilliant book. I don't have the reference here, but it's in my office in London, of course, but it's a great book. So Ethel Elderton publishes with Carl Pearson in Biometrica, and is the highest number of papers by a woman in that decade belong to her. There are quite interesting names here. Major Greenwood, again, just to clarify, a lot of people here already know that, but Major was his name. He wasn't a major in the army, or was he? I can't remember, but he really was called Major Greenwood. And that's his publications. He's a very important person, as we're going to see. More and more people. George, is he George? Yes, Otney Yule, anyway, publishes in RSS. A very important person. He wrote a treatise of mathematical statistics in the 1900s or 1910s, and again he has a part in the talk today. This is I can't remember her name. Sorry, she's called Anne Lee. In fact, she again publishes. She's a very important evolutionary biologist more than anything else. But in World War I, worked in the Ministry of Munitions, as Tim mentioned, along with Francis Wood, and indeed with Hilda Woods. So another interesting statistician, a bit older than the ones that interest us most, perhaps. Julia Bell is a fascinating story, and I'm going to talk a bit more about her, so I'll get back to her in a moment. Frances Wood, I'll talk about her as well in a moment. And these three women who published in the 1910s, they were research assistants in Carl Pearson's laboratory. I'm afraid I can't find the names at all. Sorry, I do know the names. She's called Evelyn Thompson, David, I don't know the name, and Catherine Riley, but I don't know anything else about them. But I mean, there are more and more statisticians, and I'm sure the history of these years is waiting to be written properly. But there's a lot of very interesting material. Somebody who doesn't appear here, and I should mention her now, is Ethel Newbold. I mean, she was fantastic, and again published very little that decade. She was slightly younger, and again, very brilliant mathematicians, statisticians. I don't have time to talk about all of them, but certainly Newbold, who has been the subject of biographies and so on, is another very important character in statistics at this time. Well, statistics became, in fact, I mean, as you know, the word statistics come from the Latin status, as in states, the things of the state. You just have to remember the census in Roman times, how important it was to collect official statistics 2,000 years ago. And that's the point of statistics. It starts as official statistics, then moves towards demography, perhaps with the 17th century bills of mortality and John Ground, things like that. But it really becomes a rigorous subject in mathematics after the second half of the 19th century. Adolphe Quetelet, who was mentioned by Ali in his talk, Lexis, who every demography student knows, Corrado Gini in Italy, Mayo Smith in the US, they all start thinking about probability and statistics more or less as we know that. I mean, it takes a long time, but they really put the basis for this. And in the 1910s, there were very important developments in medical statistics in the UK, not only medical stats, experimental design, hypothesis testing, and as I mentioned about Fisher's 1914 paper, methods to use for small data samples. In his case, the correlation coefficient, students T, again, is an example of this type of development in that time. Official statistics, again, major improvements were made. And if you read, there's a fantastic book about the census, all the censuses of the UK, which I didn't put in the reference, I just remember now. For the first time, the census in 1921 included a lot more detail than previous censuses. A big effort was made to collect again after the war official statistics in a professional way. So many improvements happened in this decade, which is fascinating, I think. Well, I would like to make a reference. I don't know if you know about this, but there's somebody called A.E.L. Davis from UCL, actually, but I can't trace. In fact, I don't know if he's a him or a her, I'm afraid. Somebody might know better than I do. He or she collected a lot of data from 2,500 women who graduated in mathematics from universities in Britain and Ireland between 1880 and 1940. Davis wrote a paper which is referenced at the end of the talk, and you should have a look at that. It's a fascinating resource if you're interested in this case, mathematics, women with mathematics degree in those 60-year periods. The data are available from the History of Mathematics website maintained by St. Andrews University, and that's a reference. And as I said, there's another reference to it at the end of the talk. Well, this is a picture of those data. By the way, if anybody wants the data set, I have them. I edited them a bit to make them more accessible to R. Very happy to share. So send me an email and I'll send you the Excel spreadsheet or whatever you like, and you can do these things very quickly. This is in log scale, and the y-axis is the number of graduates in mathematics, men and women. You can see the huge effect in men, particularly, of the First World War. But in women, it more or less continues perhaps at a constant rate of increase in these years too. Well, let's have a look at with more detail at this historical archive. There are differences by a university. So there are 20 universities represented. As you can see, some of them: Trinity College Dublin, National University of Ireland, Queen's University in Belfast, Scottish University like Aberdeen, and so on. They shaded. Apologies for the graph. I mean, if anybody knows how to do this graph better, please let me know. But Geom Ribbon is a pain in ggplot2. So this is Aberdeen again in log scale, Birmingham, Cambridge, and Oxford. Notably, very few maths graduates in Oxford during the war years. Then it becomes much fewer than Cambridge. I mean, it basically never reaches even 10 women graduates in mathematics per year in Oxford, while Cambridge remains at around, well, 20, perhaps 10, 15, and 20 more or less. And the university which is driving this is London, the London colleges. There are three categories for London. This is London universities, mostly UCL. Don't worry about that. This is degrees awarded externally. So this is people who study in other universities but sat the exams of the London University for mathematics. And this is the internal degrees from London. You can see the effect, I guess, from the Women's College, Royal Holloway. I don't know which women colleges they were, but there must be 2 or 3. And these are the ones which are driving graduates in mathematics in London. Glasgow, the Scottish University, is doing quite well in the war in the sense of increasing perhaps Edinburgh, Glasgow, Aberdeen too. The St Andrews, not really, the number of women graduates. Well, this is the proportion of women graduates in mathematics. Again, you can see the massive increase during the war years. Over 60% of all graduates in mathematics were women. And of course, that very quickly comes back to more or less the trend that it had before the war. But this is astonishing. I think it's a nice statistic that, during the war years, 60%, over 60% of graduates in maths were women. Well, this is the proportion of women. Again, you can see these are very small numbers, of course, but you can see Aberdeen, Edinburgh, Glasgow doing very well during the war. In fact, for Glasgow, most of the graduates in mathematics were women. St Andrews, not so well, perhaps, well, apart from London. Well, no, they do well too. Manchester, London, what else? St Andrews, I said. The Irish ones, well, not that well. So anyway, that's what's happened. And you can see that Cambridge and Oxford particularly, just there was an effect on the war, but not as big, although of course the numbers are much smaller as it was in Glasgow, in Cambridge, in Glasgow and in Edinburgh, Cambridge and Oxford, much smaller effects, let's say, than the Scottish universities, although the Scottish university numbers are much smaller, of course, of total number of graduates. Well, let me talk about 3 examples, if you like, of active women being active in statistics in the 1910s. The first one is Julia Bell, lived to 100 years, never married, and a graduate of Cambridge, of course. At that time, as Tim observes in his paper on Francis Good, Cambridge started allowing degrees or awarding degrees to women in 1948, as opposed to UCL, which started awarding degrees to women since the beginning, probably 1836, I'm not sure. Anyway, however, women were allowed, so to speak, to take the mathematical tripos at Cambridge since 1901. And no, before that, since 1880, I think they started taking the tripos, although the degree wasn't awarded until much later. Anyway, Julia Bell worked investigating solar parallax in Cambridge, and she did have a degree around this time in 1909 from Trinity College Dublin on the strength of her work. As you know, Gauss and other people, Laplace, did a lot of research on astronomic quantities, astronomic measurements, and that led to very important statistics in the 1810s, perhaps a year later. Anyway, she did all this work, was awarded an MA from Trinity Dublin. and started working after 6 years at Cambridge with Carl Pearson at UCL. She lasted 6 years there, did a diploma in medicine, trained in medicine in the only institution in London anyway that allowed degrees for medicine, for women in medicine, the Royal Free Hospital, gets her medical degree, and comes back to UCL to be a research fellow in the Galton Laboratory, and then moves until her retirement to the National Neurological Hospital in Queen Square in London. She retired age 65 during the Second World War, but continued working until 1965. And there's a lot of very, very important aspects of her work in medical genetics, syndrome named after her, and so on. There's a very nice biography by Susan Bondi in the Journal of Medical Biography 25 years ago. And that's all I'd say. It's a nice picture of her. I suppose this is taking her degree in Dublin. I'm not sure when this was, I'm sorry. But that's her. And the next person is perhaps very, very remarkable, Frances Good. That's a picture of her from the paper by Tim Cole in Significance. Remarkable person. She graduated in chemistry from UCL in 1908. She had also 4 sisters who were graduates, which was really exceptional at that time. Major Greenwood brought it to work in the statistics department at the Lister Institute, where he was head of the department. Followed Major Greenwood and moved to the Board of Trade in 1914, transferred to the Ministry of Munitions 2 years later, and she remained until she resigned. As Tim mentioned, she was married, but on account of her pregnancy, she resigned. She had many firsts. She was the first female member of the RSS Council, the first in the RSS Committee, Executive Committee, appointed OBE, and a very sad story. Her daughter is born in 1919, and she dies a few days rather later, following a cesarean section. So obviously her death was much lamented. The RSS established a memorial prize in her name in 1920. It came in disuse in the 1970s, I think, and it was restored. Again, Tim was instrumental, I understand, to restore this homage to Frances Good as the Wood Medal. And the full story of Frances, the biography, is this wonderful paper by Tim in Significance. Just two more things about Frances. One is the memorial establishing the prize with her name, signed by Alan Flocks, who was quite significant. Well, Winifred Smith, I haven't found her, unless she is, no, I don't know who she is. In fact, again, probably somebody knows. And I'm very proud that this year's recipient of the Wood Medal was my colleague Katie Harron, for her work in record linkage. Something which, again, is worth pointing out, and that reflects the diversity and the many strengths of Frances Good work, is that the prize, the Wood Medal, is awarded for contributions to economic or social statistics. So that's how the citation of the prize goes. And again, you can see all about the Wood Medal in this website, and in fact in Tim's paper in Significance. Well, let's talk about our third women statistician this time, Hilda Woods. Educated at home and at Girls' High School in Nottingham, she studied music to a degree, or to at least a licentiate, whatever it is, in piano in the Royal Academy of Music in London. Very sadly, again, her fiancé is killed in France in 1915, and it's a really amazing story. I mean, if you read the papers by Byrne Farewell and Tony Johnson, which are in the references, I mean, I'm not going to repeat what they say, apart from passing in touching, but I do urge you to read their papers. I mean, it's a brilliant story. I mean, she arrives in London and literally by chance meets Major Greenwood, who invites her, says, do you know mathematics? Well, yes. Can you count? Yes. Well, so they give her a big machine to count, to do operations, divisions, products, addition, called the Grandad. She, of course, masters how to work with that in a few days. So she starts working as a statistician. She's all her life, she becomes a statistician and writes papers on tuberculosis and industrial conditions in these 3 years. And this leads to a report, which I'll be talking about in a moment, on industrial accidents during the war in the Ministry of Munitions, co-authored with Major Greenwood. Well, that's the report. as you can see, she's the co-author of that, and is the incidence of industrial accidents upon individuals. This is done by Industrial Fatigue Research Board, who wanted to, well, obviously decrease the number of accidents and lead at the same time to more efficiency in the fabrication of things, I guess. And that's what happened. So I copied these 2 pages from that report, and I mean, everybody would recognize what this is. That's a Poisson distribution, and perhaps, I'm sure you would, this is the negative binomial distribution in a very funny way. And indeed, they named that the unequal liabilities model. I'll get back to that model in a moment, but you know, this sounds almost quite modern. I mean, the way in which they mention that for the Poisson, a bit more complicated for the negative binomial, but everything is there really that you would recognize the gamma distribution and so on for these 2 models. Well, that's all. The photographs, by the way, come from the paper by Bern Farewell and Tony Johnson, and indeed Rosemary Gier, who was, as we will see, the adoptive daughter of Dr. Woods. Anyway, so she moves at the end of the war, from the Lister Institute, after being seconded with Greenwood to the Ministry of Munitions. She moves to the to the Ministry of Health's Statistical Services, co-authors a paper in Biometrica not with Greenwood actually, but with Greenwood's wife, on height and weight of patients in mental hospitals. She becomes a fellow of the RSS in 1926 and remains in the society until at least 1951. She becomes, in 1928, the first female lecturer in the School of High and Tropical Medicine in London, in the division of epidemiology and vital statistics, which was headed by Greenwood. So that's Greenwood, Major Greenwood, and Hilda Woods. That's Major Greenwood in a very nice photograph anyway. She becomes a permanent lecturer in School of Hygiene, writes papers on respiratory diseases, scarlet fever, diphtheria, and also an interesting paper comparing graphical and algebraic methods of interpolation in life tables, which I haven't really seen in detail, but it's an interesting, again, these days in which everything is visualization, this is an interesting, perhaps, background to these things is quite good. She publishes in 1931 the first textbook on the subject, An Introduction to Medical Statistics. Again, that has been the subject of a paper by Bern Farewell and Tony Johnson. And in 1933, she's awarded a doctorate of science by the University of London. Like we have been listening to many times, her engagement in 1933 means that she has to relinquish her tenure at the School of Hygiene and marries Roger. I can't pronounce his name. Marries Roger. I'm not going to attempt to pronounce it because, yes. So she moves to Ceylon, as it was, to marry in 1933. Unfortunately, that's a Beamer, and later, of course, it doesn't put the whole thing. But what is after that? Her husband dies 2 months later, very sadly, in Ceylon from septicemia, and she's left again, alone there. And well, that's her in 1934. Now let's go back to around that time, and this is a quote from Farewell, Johnson, and Gier in 2012 in Journal of RSSA. In her late 30s, Hilda Woods wrote a short document concerning her start in medical statistics in 1916, entitled The Birth of a Medical Statistician, and it starts like this, which is a wonderful start, perhaps. I had to look up what a flapper was. Helpfully, Bern and Tony Johnson and Rosemary Gier describe what a flapper was, and in case you wonder, this is a flapper. Defined in the 1920s, and Greenwood, of course, uses the word in a descriptive but not a derogatory sense. He uses that in letters, affectionate letters, in fact, to Hilda Woods. They were very good friends. And anyway, again, please read this paper. I mean, this is a very brilliant biography. Rosemary Gier, in fact, is Hilda Woods' adoptive daughter. Well, let's go back to 1934. She works then in Ceylon as an official statistician, and then studying prevalence of diseases, lectures at University College in Colombo for 4 years, is appointed an MBE for her work in Ceylon, returns in 1938 to England, and immediately joins a research team at the Ministry of Food, researching on vitamins and minerals. She becomes this might interest him, a member of the Nutrition Society in 1945, and in 1946 emigrates to Kenya with her brother. Had a farm there, and she moves there. And again, tragedy strikes, and her sister-in-law dies the same day, in fact, that she gives birth to her niece, to Hilda Woods' niece Rosemary. She adopts her, in fact, and lives with her brother and Rosemary in New Zealand, Australia, Rhodesia, it was, and returns to England in 1958. She's retired from statistics at that point, moves to South Africa, where her daughter lives, in 1970, and dies there in 1971. Again, that's I guess the definite biography of Hilda Woods, published 9 years ago in RSSA. That's a very nice picture. That's from another paper, in fact, of Fairwell and Johnson, Statistics in Medicine, and that's Hilda Woods in her robes of the University of London doctorate. Oh, in fact, there's a Twitter account who deals with academic dress. I should perhaps point them in this direction. Anyway, so that's 1933, Hilda Woods as a doctor of science. Well, let's talk about the paper which I have mentioned. In fact, there's two papers. One is the 1919
Sorry, Maggie, just to say we have 4 more minutes for the end of the whole event.
That's no problem at all. Yes, I will finish earlier probably. Anyway, this is the paper by Otney Yule and Major Gringold in 1920, and they construct statistical models to fit empirical distribution of accidents in munitions, which were horrendous. The data were first collected and analyzed by Hilda Woods in the 1919 report, which I have already mentioned, and then Gringold and Otney Yule wrote this paper. It's quite difficult to follow, but it's recognizable what they are doing very much. I like better the explanation in the report by Gringold and Woods. It's difficult to ascertain what was the exact participation in that report in the analysis of Hilda Woods, although she clearly collected all the data and helped summarizing them and so on. Just to give you a very quick idea, I'll get back to this table in a moment. Well, I will skip the part of the negative binomial, nice as it is, but since I have only 3 minutes, recall that the negative binomial can be constructed in many ways, but one of them is as a mixture distribution. If you put a gamma density on couple a gamma density with the parameter lambda of the Poisson model, you get the negative binomial, as it's very well known. There are other methods to cope with even larger over dispersion, the Hermite and my favorite model, the Sichel distribution. You can fit them very nicely in R using these two libraries. And just very, very quickly, an example of the report in 1919. These are a random sample of 198 women and how many accidents they had in a 6-month study period. So there were 69 women with 0 accidents, 7 women, one woman with 7 accidents in that period. That's the fitted values. I did that in R, which I'm sure they would very much have appreciated. I mean, they fit the models with the moments, the method of moments, which is quite straightforward actually, but you have to iterate and so on. No, you don't have to iterate. You have to solve the 2 equations. As you can see, the negative binomial gives a reasonably good fit, perhaps not very good there. And if you use the Bayesian information criterion or a chi-square criterion, you reject the hypothesis and so on. And it's the best model compared with this, with other discrete distributions, Poisson and Sichel. Well, that's all I have to say. Apart from, please, if you have time, have a look at the references. John Aldrich paper, and in fact, I forgot to put the other paper by John in the International Electronic Journal of History of Statistics about the environment of statistics in 1910s. This is the biography I mentioned from Julia Bell. That's the paper by Tinkle on Francis Good. This is a really nice reflection by David Cox about the first 10 years of biometrica. And this is the resource I mentioned, the archive by Davis, which you can access in the University of St. Andrews. These are the papers by Vern Fairwell and Tony Johnson. Again, they are really brilliant, and you can just have a look at that if you're interested in Hilda Woods. And finally, these are the papers by Major Gringold. This is the paper by Hilda Woods I mentioned on heights and weights of patients in mental health hospitals. That's the paper by Greenwood and Yule, and the paper by the report, I'm sorry, by Greenwood and Woods. Finally, two papers about history. One is the one by I.D. Hill on a history of the RSS between 1834 and 1934, and by Pattison et al. On the density of factories about the variations of life expectancy in England and Wales. Sorry, I think I'm a bit late, but that's all. Thank you.
Thank you so much, Mario. I will listen to you all day, and I'm sorry I had to stop you, but
No,
we will share the PDF.
Notice, thanks.
We will share the PDF with other participants if they want further information. Is there any questions for Mario? Are there any questions for Mario? Sorry. Yes, John, please. Go ahead. John, you want to start?
Oh,
We can't hear you. Oh, sorry.
Okay, A.E.L. Davis is like J.K. Rowling, the woman. The A stands for Anne. Alas, Anne died last year. But the St Andrews Archive, the MacTutor Archive, is wonderful, so I recommend that. Something about First World War. Why were there so many women in universities? It's because there weren't any men. And what happened in the two wars in Britain was, in the First World War, the universities emptied of men because in 1914-15, because they volunteered. So the war began with no conscription, and the university just emptied. Women kept coming to university, and so the proportions of women were much higher. Second World War, if you like, David Cox's war was different, because if you were a maths undergraduate in 1939, you continued, and you expected to either join the army at the end of your degree or do statistics. And Cox, Lindley, and a host of the great people of that generation did maths in university in the war. Their First World War equivalents were at the front because they volunteered. That's what I want to say.
Sure. Thanks, John. Very interesting.
Thank you. Tony Johnson, please.
Thank you very much, Mario. You've credited Vern and I with a great deal, but what I can say really is that it was such a privilege to do this work and to bring Hilda Mary Woods to public attention. But it was work that almost never was. Vern and I had made a comparison between Hilda's textbook, Introduction to Medical Statistics, published in 1931, and Bradford Hill's book, Principles of Medical Statistics, published 6 years later. They were all in the same department, which is quite extraordinary. But we felt, having written that paper, that we really needed to know something about Hilda. And we spent 2 years trying to find some biographical information about her. But all we really knew was that in 1933, she had gone abroad to get married. And Vern and I sat down and we thought, we haven't found anything. Is there anything we can do? So we made one last attempt at it. And if that had failed, we would have given up. We asked whether by chance she had a will registered in this country, and she did. We obtained her will and her probate papers. We traced the descendants of the firm of solicitors that had actually carried through on the probate. We telephoned them, and we were very lucky in that we were passed to a solicitor, Vicky Rains, and we asked her if she would send a letter from us to Rosemary Gear. an open letter because we weren't allowed direct contact. She allowed that, and a week later I had an email from Rosemary Gear that started, "What rotten timing. I was in Cambridge last week. Now I am back home in New Zealand." So we never actually met her, but it was Rosemary Gear and Vicky Rains who actually enabled our research. And on International Women's Day, it is a privilege to be able to acknowledge what they both did. We could not have written about Hilda were it not for the contributions that Rosemary Gear made. Thank you. What I will point out in response to John's comment, Hilda Woods went to Sri Lanka, Ceylon, 1933. She married, her husband died 2 months later. She threw herself into work, notably on malaria in Sri Lanka, and was awarded an MBE as a consequence of what she had done. She came back to this country, was involved in nutrition in 1948, and finally gave up on statistics, I think, when she went abroad to bring up her daughter, Rosemary Gear. It's a story of triumph and tragedy, and it was an enormous pleasure to be able to tell it. Thank you.
Thank you, Tony.
Thank you so much. Finally, a question by Malcolm Hall, please. Malcolm?
Thank you. I'd left the mute on. It's a horrific thought that such intelligent people were forced to resign positions and apparently stop contributing because of marriage. And I'm wondering if these guys either have the chance of they can either go crazy or they can carry on doing things. I'm wondering how many women continued to work through their husbands. And I'm wondering if women who were married to academics, you could almost discern a trace through their continuing husband's work of their own influence through there and attribute achievements through that.
Well, I can't comment on that, but it's a really somber thought, I guess. Thank you, Malcolm.
Yes, I suspect it's a huge project attributing the almost rewriting our statistics to attribute women with an appropriate contribution.
Yeah.
Any other questions for Mario or Alison?
On mute. I wanted to just comment. The person I mentioned is Janet Campbell, who she worked in the public health in the Ministry of Education before the First World War, and then in 1919, when the Ministry of Health for England was founded, she was appointed to be head of the Department of Maternal and Child Health, and to lead a team of women doctors, nurses, midwives, and lady sanitary inspectors, now known as health visitors. But I mean, she was an innovator on inquiries into maternal death. She wasn't the original innovator. The first inquiry into maternal deaths was done by Matthew Hill in Aberdeen in 1917. And then this was followed by an inquiry, again, another distinguished woman who never married, Charlotte Douglas, who was head of Maternal and Child Health of Scotland, and the only maternal death inquiry to have had a control group ever. But Janet Campbell, having done a lot of individual studies, started these inquiries in 1928, and that everybody in the world of confidential inquiries will tell you that confidential inquiries in England and Wales were founded by male obstetricians in 1952, even though several of the people who were involved since 1928 were involved from 92 onwards, and they referred in the early reports to, since this inquiry began in 1928. But everybody is so locked into the obstetrician starting in 1952 that Janet Campbell's innovation is never mentioned. I think there is a whole bias there. I don't think in her case BMJ obituary referred to her cultivating her roses. Now, also, the other thing, there was a very rapid change round because in the late 30s, women had to resign on marriage unless, like Enid Charles, they were lucky enough to get a job in Aberdeen. But the moment the war started, any woman who hadn't got any children was required to work. So my mother, who was a French teacher, did a first aid course. But then again, there were, she did, I mean, again, this has nothing to do with statistics, but there were jobs which did become available. And she worked in the local boys' grammar school, a very traditional male school, to replace masters who'd been called up in the Second World War. So it may be in other professions, but not in maths and statistics, that women did go back to work in the Second World War.
Thank you, Alison. We have one last question from John Andrich.
Comments about husbands and marriage bar. Husbands, I've read a few biographies of successful husbands, and they actually make depressing reading. Frances Woods, one of Frances Woods' sisters, she married her PhD supervisor, and in later life he would always boast of her dexterity rather than her brains. She knew how to handle microscope slides. Another one is Brenda Stoisiger, who married one of Fisher's Rothamsted chums, Clapham. And again, she vanished. Her intellectual life didn't live on in his work. So that's about miserable husbands. About the marriage bar, so the marriage bar was actually enshrined in law for civil servants, including teachers. However, if you ask what was Frances Wood doing in the First World War as a married woman working for the Ministry of Musicians, war changes things. And basically, if you're useful in war, you get on whether you're married or not. At Rothamsted, for example, there was no marriage bar at all. And the famous lady who tasted tea stayed on when she married. Universities mostly had no marriage bar, but there were some exceptions. So the marriage bar killed you if you wanted to be a government scientist. It killed you if you wanted to be a civil servant, but it wasn't universally applied even there. That's all I want to say.
Thank you. Mario, you wanted to reply?
Just a very quick, just a very quick question for John. I mean, do you know until when was the marriage bar enforced?
Okay, it was removed in 1946,
right,
in Britain, and it was in, and I don't think Aberdeen was different. I think it was the UK, but how this was applied, I think, depended on individual circumstances, and I think rules were bent if the employer wanted them bent. But yeah.
Yeah. Thank you.
So, yes, Saini mentioned Janet Lane Clayton, and I was also going to ask about her because I know she was forced to stop at 1929 when she got married to the Minister Deputy of Health, but then 2 years later she was still publishing, so I don't really understand what happened there, but was that a common thing or papers that she had in the working, she finished then, or I don't really know what happened there.
I think the 1931 paper was not by her. It was repeated by somebody else, as far as I know.
Oh, I see. Oh, that makes sense then.
Yeah.
Thank you.
Yeah, she published in 1926, and then it was replicated in 1931 by Wainwright.
Okay, perfect. That makes sense. Yeah, because I couldn't really make sense of it. Great, thank you. So if there are no any other questions, I think we could come to a close.